attention. Attention is you're trying to have a signal based upon, let's say, your goals, and there is interference and noise. That's what I think of largely as distraction and then multitasking. And if you want, I could break down sort of the conceptual framework that we built to separate out distraction and multitasking. I think they're different types of interference. But both of those types of interference, distraction, which is completely irrelevant information you're trying to ignore, you want to ignore, and multitasking is when you make the decision to engage in more than one stream. Both of those types of interference can enter and cause interference, both externally or internally, and they can occur both with and without awareness.
What does it take to do the impossible? What does it take to level up your game like never before? What does it take for individuals, organizations, for even institutions to achieve paradigm shifting? Nothing is ever the same again, breakthroughs.
Our mission is to decode the neurobiology of flow and cognitive peak performance. Access the minds of maverick scientists, groundbreaking innovators, and world-leading experts to understand what it takes to achieve ultimate human performance, so you can feel your best, perform your best, and accomplish your boldest goals. I'm your host, Rian Doris, and together with best-selling author Stephen Kotler, I present to you Flow Research Collective Radio. Adam, we're stoked to have you join us and stoked to dive in. I know Stephen's got a few quick words to mention about how you guys connected in the first place and where we want to go today.
Great. Thanks for having me here.
Hey, everybody. Welcome. Thanks again for joining us. I'm incredibly excited to have Adam with us today. As Rian mentioned, he is one of our go-to guys for neuroscience. I think he's one of I think he's a rock star in the field, and he's doing some of the coolest work on attention and distraction of anybody out there. And he's probably been a little farther under the hood of some of the major flow triggers than almost anybody. So we're going to get into all that, and I'm really excited to begin. Rian, why don't you kick us off?
Totally. So Adam, let's just dive straight in. So for years now, you've been a leading expert on the distracted mind and the idea of distraction and how technology can cause interference. So with the world making a shift toward online everything during the pandemic, could you tell us a little bit about both the issues and the opportunities you see for neurological well-being, given the increased use of technology since this whole pandemic has kicked off?
Yeah, it's a great question. First of all, I just want to thank you for having me on your show. And I would say that the technology part of it is particularly fascinating, because as I, have written and talked about, including in my book, The Distracted Mind, technology has placed an incredible challenge on our brains, on how we process information, on how we relate to each other and ourselves. And now we use technology more than ever, especially children. Like, I talk to friends of mine who have kids, and they've abandoned all hope of any restraints upon their use of screens. And they're like, well, what does this mean? Because before this, we were trying to, tailor it back, or at least give some moderation. And so, I would also say that with any challenge, there's opportunity, and all swords slice both ways. So in addition to being able to understand what the challenges are from technology, I find it really fascinating to think about what is the opportunity to use technology to help us manage not just the communication like we're doing now, which is obviously very important, but really as a tool to help us enhance our minds and really thrive, if not survive. That's the goal. How do we get through this? Not just as good as we were, but somewhere better.
Love that. That makes total sense. So I'm curious, what's the most common question that you get asked about distraction and about the distracted mind?
The question that I'm asked the most, I think people are, trying to wrap their heads around how the messaging had been seemingly for so long that we should just be multitasking like crazy. You know, we have all these opportunities, all these devices, all these browser windows, and, you know, our phones are meant to switch between. And so we're given one message, and have been for a long time, that this is the way we're maximally productive. And then an alternative message has been coming out, one of which that I've been generating a lot of research for in our center at UCSF, as well as in books and talks that I give, that our brains just don't really handle this type of interaction with information very well, to use that very globally, with or without technology. So I think the most common question I'm asked is how do people reconcile what we were thinking was the route to be productive and to use technology in an optimal way, and what neuroscience is telling us is not the case. So that's probably the most common thing.
I want to jump in and ask you a question.
Yeah,
and it's sort of tied to this in a sense. I'm going to ask you, it's a two-part question. One, talk a little bit, just so people have a foundation of this, about how goals impact attention and how they serve as kind of a top-down attention mechanism. And the question I have for you is, how does long-term goals impact attention? And I'm really asking a question at like a thalamic gating kind of level. We can unpack the neuroscience along the way, but I'm really, it's been fascinating me. You're one of the only people I know in the world who really works on the goal-directed system, first of all, and is even thinking about long-term goals and how they affect perception, thalamic gating, all that sort of stuff. I'm going to take us from multitasking into the deep end of the neuroscience in a minute. But I've got you. So, you know, you're a captive audience. So I got to ask you.
No, I love it. And we've talked about this as well a bit. You know, let me create a little bit of a landscape for us to talk about attention. Attention is one of those things, even some very famous psychologists have said, oh, attention, everyone knows what it is. We think it's obvious, and we use it across every field. But attention is super complicated. If we had a whole hour to talk about attention, we would definitely not get through it all. And so I'm not going to try to unpack it in all of its beautiful complexity and nuance, but I do want to just frame it from one perspective, given your question, this idea of bottom-up and top-down attention. And then we'll talk about short-term and long-term. So the most ancient aspect of attention, the one that we evolved for our survival, is called bottom-up attention. And that's how the environment itself demands your attention based upon the salience or novelty of the stimuli. So this is what allowed our ancient ancestors, even if you go back to single-cell organisms before we had a nervous system, to survive, you know, to basically avoid threats and toxins and seek out nutrients and eventually mates. And, you know, and so our other animals, and us to some degree too, are constantly directing our attention based upon the environment itself. It demands our attention and it moves it around, and it's largely reflexive, and we retain a lot of those reflexes. So fortunately, because we still use them for survival. That's bottom up. Top down, we're as animals, as humans within our species, and as animals ourselves, that is where we're most advanced, is top down attention. Top down is where your attention is not driven by the stimuli themselves, they're driven by your goals. So you make decisions and you decide, I am going to direct my attention towards that or away from that. So that goal directed attention, or top down attention, is sort of, I would say, the pinnacle of human brain evolution. And it's what allows us to do everything that we've done, from society to language, music, technology, art. All of that demands top-down attention. But we're always in this conflict of bottom-up and top-down, right? So even now I'm struggling with it because I'm not like in the perfect setting to have this exchange. There was a horn outside, pull my attention away. I know my wife is upstairs on another call. I could sort of hear her a little bit bottom-up. And so this is how we navigate the world, whether we're aware of it or not, is balancing bottom-up and top-down. And they're always at an interface, and you're always struggling to assert your goals over the environment and vice versa. versa. And that happens every moment, right? We constantly flow through this interaction between bottom up and top down. And that's happening in the very short term. And it influences everything. It influences our memory, our perception, our decision making, our emotional regulation. All of it is being influenced by those two attentional forces. And just to like wrap up and not go off on too far on a tangent. So in terms of long-term planning, that's even more human than what other animals are capable of. And that takes even more top-down effort and control and attention. And it intersects with all those other things as well. But the real challenge of this research is understanding how those long-term goals mediate the attentional flow in the moment. And that's something that we're interested in, that we're looking at. So when you enter a situation, this is sort of the interface that I think between intention and attention. So attention are the resources, the top-down attention that lets you put your limited mental power where and when you want it. And the intentions are how you make the decision about where it is. And obviously, it's the intentions that are influenced by those long-term goals.
Adam, I think it'd be really helpful for people to distinguish between awareness and attention. Or how do you think about that?
So awareness, arousal, attention are different, right? They all intersect. Arousal is obviously just your general sense of whether you're drowsy or awake, but it intersects with your attention, and your attention, as I said, it's complicated. Attention includes focus and ignoring. And things that are usually in your top-down attention, they're in your awareness, but attention's complicated. So things that may be pulling your attention in a bottom-up way may be completely outside of your awareness, right? We call that like subconscious decisions that you make. So, they overlap. They're not like completely orthogonal, but they intersect all the time, those three concepts.
So bottom-up attention, when we talk about arousal, you're essentially talking about an acetylcholine reaction. Top-down, same thing. Is it also acetylcholine? If the minute you get excited or anxious or whatever, you've got other neurochemicals coming in. But I was just wondering if it's the same system, bottom up and top down.
Yeah, I would say so. We see the cholinergic system involved in both of those types of attentional processes. It's probably how it has a lot of its benefit in conditions like dementia, where we give cholinesterase inhibitors to boost acetylcholine levels. But it's a good question, and it's something that is an active area of research in parsing out its different roles and different types of attention. So
am I right, Adam, based on what you were saying previously, in thinking that there can be distractions that are outside of our awareness or outside of our conscious awareness, yet still distracting us, even though they don't feel like they are?
Undoubtedly. I mean, that is, it's a massive source of distraction, are bottom-up influences that could fall outside of our awareness. They could be both internal and external. That's yet another way of breaking down attention. You could direct your attention inward, like in a lot of meditation practices. You could put your attention externally. Just like your attention can be focused internally or externally, the interference in attention. So I like the concept of interference. Like it sits well with how we think about signal and noise, right? You're trying to get a signal in the radio and there's noise. That's the same thing with attention. Attention is you're trying to have a signal based upon, let's say, your goals, and there is interference and noise. That's what I think of largely as distraction and then multitasking. And if you want, I could break down sort of the conceptual framework that we built to separate out distraction and multitasking. I think they're different types of interference, but both of those types of interference, distraction, which is completely irrelevant information you're trying to ignore, you want to ignore, and multitasking is when you make the decision to engage in more than one stream. Both of those types of interference can enter and cause interference both externally or internally, and they can occur both with and without awareness.
Can I ask a weird question here? When we talk about distraction, does it register, does the anterior cingulate cortex register distraction as a kind of error correction?
Say it again, what you mean?
When we're distracted, let me back that up. When we're distracted, where does the signal show up in the brain? When we say distraction interrupts attention, what are we actually talking about at a structural level?
It depends. It depends on the type of distraction and the type of activities that you're engaged in at the moment. So as we all know, and I bet a lot of your listeners appreciate this, but I'll pause on it for a moment because it's so important. Our brain doesn't work as a bunch of separated islands of processing. It works as a network. It's an interconnected, dynamic system that is constantly shuttling information in all of its great extent of processing. Now, when you are engaged in a certain activity, let's say it's a visual activity, there's lots of areas that are associated with what's going on, right? So you have your visual cortex and the occipital lobe, where you're processing that visual information. Obviously, it's coming in through the brainstem and passed through the thalamus. But then you have the prefrontal cortex, which is where your top-down control is largely thought to be mediated from, right? And we know this is the most evolved part of our brain. We see that there's a network of there are certainly structural connections between, but functional connections between them. And then, of course, if there's memories involved, your hippocampus is part of this network, emotional salience, then you have your amygdala. And so you have this network of brain areas, and the network has to be engaged in order for you to process it in a meaningful, high fidelity manner. When we present someone with interference, we see a couple things. So if the interference is just a distraction, then what we find is that there is a loss of fidelity of the resolution of that information that's being maintained in the sensory cortex where it's being processed. So that's why I said it depends, right? So it's specific based upon whether it's auditory or visual information that you're processing at the time. And when we could see that in a whole bunch of different signals. Interestingly enough, what we find in the setting of distraction is that you can often maintain that network, but it's presumably, from at least as far as we can tell from the measurements that we do, it's still activated, although probably not, and we can know this from the behavioral data, not processing as high at a higher fidelity level. If your interference, here's my wife, bottom-up stimulus. If your interference is multitasking, right? So if it is another task that you're engaged in, then what happens is that network basically breaks down and you form a new network. And then that new network lets you approach that task with, high fidelity. And then when you switch back, you basically break down that network and reactivate another network. We've seen this with both fMRI and some degree with EEG recording as well. And so those two types of interference, distraction and multitasking, the secondary tasks, seem to have a different signature upon which they break down performance. And so that's how we, at least when we're looking at this from a neuroscience perspective, how we make sense of why we can't seem to just completely filter out everything that's irrelevant based on our goals, and why we're not able to take our attention and apply it to more than one task at a time. Because what we do not see is that we parallel process those two networks simultaneously. And so that's a little bit of the neuroscience behind distraction multitasking impacts.
So, Adam, so we've got kind of awareness, attention, arousal, interference, obviously, and they're all somewhat, interrelated and then also unrelated. Is there an analogy or a visual that you use when describing awareness versus attention versus arousal? And I've heard of that idea of, the lighthouse with the fog beam being awareness, and then a more specific, beam being attention. Do you use any kind of analogy to sort of tie a bow in that for folks?
I don't think I haven't really thought of an analogy that tie them all together. Obviously, the spotlight of attention is a classic visual analogy that we use to sort of help people understand how you can move the spotlight around and things are outside of its awareness. I don't really love the spotlight analogy, because what we've learned in our research is that it's not really like a spotlight, because what's happening is a spotlight implies like one directional influence, right? So like you're putting a light on something and everything else is denied light. That's not what we find in our research. What we find is that when you pay attention and focus on something, it's true, it's getting the lion's share of your processing, and you see tons of different neural indicators showing that that's true. But what we have found is that your processing of the irrelevant information is not just denied the focus. It's actually actively suppressed. And so I view both attending and ignoring as active processes. And we've actually shown in our research that they can be dissociated. One of our first papers showed that older adults are able to focus like 20-year-olds, but not ignore. And that's what creates all of their attentional problems.
Oh, wow.
Adam, I want to follow up on that. So the finding, correct me if I'm wrong, but my understanding of it is that older adults, and it takes place in like the first 1/10 of a second, right? That they don't suppress information like younger people. So what changes? Is that a thalamic gating thing? Like what is going on there that degrades in older people?
Yeah. So we had a series of papers. I mean, it's been
a while.
You know, it's been like 13, 14 years ago from some of those first papers. And what we showed was that it was actually started with a Nature Neuroscience paper where we showed that there was a selective suppression deficit in older adults. That was done with fMRI. Showed that if you use measures of focus, they were preserved. They looked like 20-year-olds. Where they were failing was the ignore side. And the degree that they failed, like if one older adult, healthy 60 to 80-year-olds, if one older adult failed to engage their suppression mechanisms, that directly related to their memory of the relevant information. So showing that it had like real meaningfulness to how you process information because it creates interference. We showed in another paper in PNAS that we followed up, doing it with EEG, where we could look at the temporal details of this, right? The timing specifications, that this failure to suppress irrelevant information occurs very, very rapidly within hundreds of milliseconds. Now, so you may think that, wow, anything occurring so fast is happening, you know, right basically from thalamus to, you know, to visual cortex and is not really subject to top-down processing. And that was actually a dominant view in the literature when we published this paper. But then what we showed here with a couple of different manipulations is that based upon your top-down goals, so clearly beyond the thalamus, prefrontal cortical areas, you're able to modulate activity in visual cortex within like 150 milliseconds. So really, really fast. So yes, we believe that it probably involves the, you know, some gating of the transfer of information from like thalamic areas to visual cortex or whatever, you know, sensory cortex we're talking about, but it is under top-down control. So it's very fast that you get to apply this. So our conclusion was that older adults are not able, it's not that they can't filter at all. They could suppress, but if you don't do it right at the beginning, like, you know, 0 milliseconds on, if it hasn't started, then irrelevant information comes in and creates interference with the relevant signal, and then you get all those negative effects.
Let me ask you next a follow-up, which is John Koinos-Marby and a number of other researchers who work on creativity find that one of the things that's consistent with creatives and the brains of creatives is they don't have repetition suppression, right? They don't as much. They perceive familiar stimuli as novel instead of as, oh, I've seen this a million times, right? Because that gives them more novelty, which is the foundation of pattern recognition, which leads to more creativity. So does this mean, because older adults don't, is it a different repetition suppression? It's the same kind of mechanism we're talking about here? Does this mean, I know there's a spike in creativity in people over 50. Is this why? And by retraining the brain to focus like that, is there a creative cost? Are these just weird ass questions?
No, it's a good question. Repetition suppression is different than this type of top-down suppression. Our brain does all sorts of suppression as part of perceptual processing. So it's a very complicated topic, and we probably don't have time to like tear through all of the different aspects of suppression. I mean, I love the whole idea of suppression. If you think about like bonsai, like creation, right? Like a lot of it is the pruning process, and even sculpting in general is like you have the clay and then you pull things away. It's very much like that with perceptual processing. A lot of the real power is what is removed from it, not just what is added in. In terms of suppression and creativity, I back in the day, you know, I haven't studied this particular topic of aging and suppression recently, but back in the day, this was a constant area of of questioning, because a lot of older adults were like, but the fact that I can't suppress is a good thing because I'm taking in more information and it stimulates my creativity. I had this whole like sort of not battle, but this whole discussion with another researcher in, I think it was in the New York Times, about how losing suppression ability might be good. I would say.
What do you mean? I'm not the first guy down this road?
Yeah.
Damn.
No, not the first. It's been a long time though, so I'm like trying to refresh my memory. So yes, I think that sure, if you suppress everything so like well that you basically create a tunnel vision for yourself and you can't bring in new information, then sure, it could restrict a lot of creative processes. I think that makes sense. The reality is, though, if you can't suppress and you are just having a flood of new information all the time, I would argue that that is going to be interference in the goal-directed processes that are required to make your creativity actually productive.
It would sound
So
okay.
to do something with it. So maybe you're a brilliant artist because you're seeing all these things and these things are happening, but maybe no one is ever going to know about that because you're not able of putting it together and delivering it. So, somewhere in the middle is probably the sweet spot.
Right.
Got it.
Got loads of amazing points here. So ignoring is an active process. I want to reiterate that for people. Then you've got attending and ignoring, and the idea around suppression. When it comes to attempting to increase focus and reduce distraction, do you think about strategies through the lens of things that increase our ability to attend and decrease what we have to ignore? Is that the simple way to parse out different strategies or techniques?
Yeah, I mean, in the simplest way, if suppression is an active process and demands resources, one of the strategies is to just decrease the amount of distracting information around you, right? So that you could take more of your resources and apply it to focusing on what's relevant, which is, a very classic strategy of minimizing your workspace, of decreasing the number of browsers are open, trying to single task when you're doing something that really requires high level processing. So I would say that neuroscientific nugget is directly applicable to this idea of minimizing clutter, both external clutter and internal clutter in your mind.
Yeah, I think it was you who said that, just literally the option to check your phone is itself a distraction. In other words, because obviously it's playing on suppression in that respect. So no, that's super interesting, super helpful and practical. And then just on the practical application note, what are the standard strategies, tools, tips that you recommend for folks to improve focus, reduce digital distraction, etc.?
Well, the first one we just talked about, clutter, and that's probably more important and challenging now, like just to make this COVID relevant, because like we're all in this situation, probably almost everyone on this discussion is at home in a place that is probably not optimized for focus, and maybe more optimized for interactions with your family, which seems appropriate, or relaxing, or dinner. You could see I'm struggling with trying to make my environment conducive as well. But since we've been home, I've been working on that to make my workspace able to you can't really see what I'm seeing, but to have a nice clean palette to be able to focus on. So that's really important. And then remember, I also said that the clutter could happen inside as well as outside. So another challenge, you're worried about this or that. All of those are internal sources of distraction, and they will be unrelentless, and they will impair your productivity and your performance just as much as external clutter. So that's one thing. And there's no simple answer, right? It just takes practice, new habit formations and management, and maybe principally being aware of it, being able to be introspective about the sources of interference in your life. And it might not just be productivity that it's interfering with. It could be your relationships, your connection with people you care about. It could be interference with your sleep, and tons of different ways that interference has negative consequences. The next thing I would say is learning. Again, it's a little bit metacognitive. It's learning yourself and understanding that fatigue is not just something that's related to our physical bodies. Like, we've wrapped our heads around that really well. Even like Olympic athletes and professional athletes of all kind know that if they are going to continue to engage in their training or their performance activities at a high level, they need to have rest. They need to restore from fatigue so that they can re-engage at that level and maximize their learning and growth. It's the same thing for your brain. We will fatigue, and we require restorative periods in order to re-engage. It's much less research for the brain than it is for physical body and muscle type of fatigue. And so I'd say, for people that are trying to learn how to focus better, one of the practices that I engage in is to take a healthy and open look at what you do to restore and when you restore. And do you put in scheduled breaks in order to allow yourself to recover? Or do you think that's a sign of weakness, as I think a lot of people used to do, including a lot of employers, and think that you just have to push through 8 hours of uninterrupted activity, which is likely impossible? And then the next question is, what is the break that you're taking? Is it going on social media where you just go down these iterative sinkholes and it gets more and more complicated in order for you to get out? I would say that the breaks, from my impression, that are ideal are a little physical fitness. So if you could do a little walking, some push-ups, something to stimulate yourself physically, being able to shut down the noise, whether it's like meditation that allows you to have a solitary focus. So I think that those are two really good activities. Probably one of the best is to being able to engage in nature. Now, that might not be easy depending where people are located, but sometimes I'll even look at something as simple as a screensaver of nature photography to be able to just allow the mind to free itself from the top-down goals. So the message here is that if you want to restore your top-down attention, one effective way of why nature is effective is to have a strong bottom-up influence that allows you to just take a journey.
I want to ask you a quick question. It's a little related, a little different. You talked, I think it was a lecture you gave at UC Irvine a couple years ago. You mentioned that texting impacts reading retention. And you said you were going to follow up on it or were thinking about it. I wanted to know if you ever did follow up on it. The idea that because texting breaks up language and we don't use language normally when we go to read books, the fact that we're texting in weird ways is actually impacting our reading retention. Is that something you followed up on? Is that real?
Yeah.
Do we know that?
No, we haven't engaged in that study. I remember we were talking about that, but it's something we haven't really pursued.
Ryan.
So I got one more question, Adam, on this whole topic. So you hear a lot of people talk about, 21st century brain melt, dopamine addiction. Dr. Ned Hallowell at Harvard has that idea of attention deficit trait. What is happening neurobiologically over time with chronic exposure to massive excessive distraction?
We know a lot about the impact of distraction, interference, multitasking like crazy on acute performance, right? It's very empirically accessible. You can do a study where you have someone focusing and then you throw something at them to interrupt them. And so most of the data that you read, everything that I was just talking to you about was based upon acute interference. I was just, since it just happened, that echoing is like a perfect example. Like just suppressing that bottom-up information was really exhausting for me and really hard to maintain high-level thinking. And so that would be like a perfect study to do that with and without echo. And so it's just what we know the most about. What we know the least about is the long-term chronic effects of engaging in a certain environment, just because it's very hard to study. It's very hard to control. There are so many factors that are present and variables that lead to a lack of interpretation. if you look at the data on the relationship between how people multitask in their daily lives and what their cognitive abilities are when you test them in the laboratory, what you find is that people that are heavy media multitaskers, and we've done a little bit of this work, most of this work is done by other groups, what you find is that they're actually not very good at multitasking. If you look at them in the lab, they're worse than the people that are multitasking less. And not just multitasking, their attentional, speed of attentional deployment, resistance of distraction. And so that's an interesting piece of data, but it's correlational, right? We don't know for sure that because they multitask all the time with their media, that somehow it has suppressed their ability, their cognitive control skills. It's possible, but it doesn't mean that. An alternative interpretation is that people that engage in their media consumption in that manner don't have good cognitive control skills to start with, and that's why they behave that way. So that's like always the challenge of correlational data. And so we're still missing, we actually have work that we're doing now in collaboration with a group at Stanford to try to get a little bit more causal data about how your interaction with the world around you, especially media, impacts you in the long term. And is that causal?
That makes total sense. All of your work on distraction is just phenomenal. And just want to mention your book as well. Do you mind quickly telling people about your book? And then I got a question for you about tech to switch gears a little bit.
Yeah. So, the book is called The Distracted Mind, Ancient Brains in a High-Tech World. And really, it's an evolutionary perspective on how our brains evolved to give us all these amazing strengths, especially goal-directed attention, and how technology has challenged us in a very fundamental way. And, it's mostly a science book that I wrote with a colleague, Larry Rosen, who's done a lot of the field psychology. So I talk about a lot of the neuroscience. He talks a lot of the real-world stuff, what happens when children use social media and how it impacts their attention and things of that nature. And then we give some practical tips at the end. So it's a couple years out, but I think it's still highly relevant, especially today. It's an area that I don't engage in research right now. I've sort of flipped everything around almost a decade ago of instead of talking about the problem of distraction and interference and technology, trying to use technology to create tools to help improve cognition.
Yeah, that's where I'd love to go, because you do an amazing job of balancing both sides of technology. So what are the technologies currently that you're interested in, working on? Where's the edge of the research? What are you most excited about with respect to the intersection of neuroscience and technology?
Talk about NeuroRacer, Adam.
Sure. Okay, so let's start with NeuroRacer. So a decade ago, I was basically doing research that you just heard. Everything, we just covered all that: distraction, interference, multitasking, aging, all those aspects. And I got frustrated to think that I was going to spend the rest of my life just reporting the bad news, that we're very susceptible to interference, that our brains get worse as we get older. And I wanted to flip it around. I thought that technology has a lot of promise in helping how we function. And so I had this idea, which seemed maybe a little crazy at the time, and maybe to some it still does, but we've come a long way. So this is 12 years ago now, 2008. I came up with the idea of building an interactive experience as a cognitive enhancement tool, specifically delivered as a closed loop video game. So I'll just talk a little bit about the closed loop and its role in technology implementations to improve cognition. So a closed loop is one in which, first of all, it's a larger term than I'm using here, right? You have closed loop systems in your home right now. Your thermostat is detecting the ambient temperature in your home and then adjusting in real time a heating or cooling system to maintain an equilibrium. So a closed loop system takes in data and then uses that data in some actionable way and puts it out. So it's like a feedback system. We have very little of these for human biology, actually. And so the idea of a closed loop video game is one where a participant is being presented an experience through digital technology, right? Which is what we do all day long when we do anything, playing a video game being one example. But instead of a game that just keeps challenging you or rewarding you in some way that's preset, a closed loop video game is recording data about your ability to engage in it. And I'll dive into that because that's some of the fun stuff we're working on now. And then it's adjusting the elements of the experience that you're receiving, the stimuli, the challenge, and the reward, such that it creates a personalized, targeted experience. And my hypothesis was that these type of closed loop experiences can really allow us to optimize the function of the brain. First of all, because the experience itself can be constructed in such a way to activate brain networks in a selective way. As a matter of fact, I would go so far as to say the only way we've ever selectively activated brain networks is through experience. We've never had a drug or neurostimulated to activate, full complex brain networks in that manner. But that's how the brain works. You engage in an experience and your brain responds selectively. So that's the first thing, is that the nature of the experience has selectivity in terms of its network activation. The next thing is that the closed loop aspect of it is constantly putting pressure on it. So what we can do with your data, let's say your performance data, is to create a challenge and a reward system that pushes you right to the level of your ability, but not so far that you're just completely frustrated and stop, or not so easy that you just give up. And what that allows us to do is to take that network that's now selectively activated and apply continuous pressure to it over time. Your brain's own inherent plasticity will act to improve function by any network that's engaged in such a manner. And so that's like a little bit of the idea behind NeuroRacer. Now, all of the technology that we've created at Neuroscape, which is our research center at UCSF. And so just to wrap up this part of the story, what we've been doing over the last decade is first building technologies that use closed loop systems to apply pressure to different networks and improve cognitive function. So we both create our technology in-house, and then we do deep dive research studies to validate how it works, and both also to couple that with neural and physiological recordings so that we can understand the mechanisms of action. So the NeuroRacer, which was our first game from 2008, and then eventually became a research paper published in Nature in 2013, really described our ability to use a closed-loop video game to improve attention abilities in older adults outside of the gameplay. And this had two different control groups. We looked at sustainability of some of these effects months later, and by recording EEG activity during gameplay before and after, we understood the neural mechanisms of this change. And so that's like the framework of everything we do, both at Neuroscape and several companies that I started as well, to use closed loop systems in technology to drive cognitive enhancement.
Amazing. I love it. And it maps so tightly, obviously, to flow and what produces flow. So just to make sure I'm tracking correctly, when you say closed loop systems, the fundamental elements of that are in flow language feedback, so immediate feedback, and then the challenge skills balance, and then the constant kind of modulation of that to keep the perfect level of stimulation. Is that right?
Exactly. And that can occur. It can occur with very simple metrics about you, like your performance. So just speed and accuracy would be one level. But what we're exploring now, so all of our first games that we created were really, our first foray into the space was just using performance metrics. So just speed, accuracy, other type of psychophysics metrics that we could gather with just simple sensors on devices. Now we have a program that we're really excited about, and I talked to Stephen a little bit about this. It's called our multimodal biosensing program. And our goal here is to capture, jokingly, internally, we call it the full metal jacket. Basically, any signals that we could capture about an individual, especially the dynamic ones in the moment, we are looking to do that, and then to as rapidly as possible process that information. So this involves a lot of activities on sensor technology, signal processing, machine learning, to make an interpretable sort of composite of those signals that then we can use essentially as close to real time as possible to update the environment. So this is where we're heading, is how do we advance both the input side through multimodal biosensing, essentially real-time state recording, and then how do we present that experience back to you in a richer way. And for that, we have a lot of work going on in full sensory immersion. So taking VR to the next level. Hear, see, smell, feel, all of that updated based upon that data. That's the next generation of the closed loop. That's what I spend a lot of my time working on and thinking about how to accomplish.
Yeah, the power of that with VR is just Wild. Just got a really quick question. Can you tell us a little bit about the background behind closed loop and why it's called a closed loop system? I'm just curious about that. And then, then I've got another question for you on this.
Yeah, it's an engineering term, and it's used in many, many different fields. And basically, as opposed to an open loop where you do something, there's no feedback of any information about how you do, and you just keep applying again. Many things in the real world are open loop, right? You don't have that tight cycle between what you do and then what comes back to you. I mean, sometimes you do in quite a nice way, but a lot of times it could be very long. Like, for example, our education process is fairly open loop in my mind, right? So a student consumes information, and then they consume, months pass, then they spit that information out as best they can in a test, and then that information is in no way used. I mean, the data that you get from that is no way used to update what they learned, right? So there's a disconnect. It's an open loop. It's like an open, circuit. And so the closed loop just the ideal closed loop is real time, constantly cycling over and over again. So, that's why it's the loop. So information flows in, and then the environment flows out.
I just want to build on that with a quick question. So when you look at the literature surrounding the challenge, skills, balance, and flow, there has been a 20-year debate on what do we mean exactly by challenge? What do we mean exactly by skills? For example, among elite athletes, there's studies that show 80%, because talent tends to sort of standardize as you move up. 80% of what we mean by challenge and skills at the elite level can come down to confidence. When you look at things like that, when you look at questions around challenge and skills in terms of how you're optimizing it, how do you think about it?
This is, we have this whole set of challenges as we move forward in our process of understanding what are the elements that we could create the most effective cognitive enhancement technologies. That's something that drives all of my thinking. And when I say cognitive enhancement technologies, I mean that it can be applied to people that are healthy, people that are already high performance that are looking for 1% more, or people that are impaired and have pathology and would fall into neurological and psychiatric diagnoses. So we look across the entire gamut. And we spent pretty much the last decade on trying to understand how we implement the closed loop system, how we're more sophisticated about the algorithms we use, how we could collect richer, more comprehensive data that capture a person's state, how we present that information in more immersive ways, more real world ways. And that's what we've worked on. Now, one of the many things that I've sort of plotted for our next decade challenge is all of these other factors that then go into making this type of technology useful or not. So some of it is, what are the we could talk about the field of psychedelics if you're interested, and we're actually entering that phase soon of integrating it with our technologies. I don't want to create a distraction here, but the reason I bring it up is because if you look at the psychedelic research field, this concept of set and setting is like baked into every discussion that happens, right? What are the things that occur before the treatment, during the treatment, and then after? So the priming, the intention setting, and then on the other side, the processing and integration. We haven't done that part of this equation when it comes to technology-based interventions. It's something I'm really interested in. So from confidence to motivation to establishing safety, goals, an appropriate mindset to be able to learn and to expand. And then how do you really integrate it afterwards into your life, which is complicated and has all the factors that might have prevented you from doing well in the first place. So it's a great question. To me, you could feel like the weight of it because there are so many variables there, but it is our next frontier.
One of the things that I find really interesting about it, and it shows, you see this, a lot of the other pre-performance thinkers thought that you had to get past culture. That culture, what we mean by challenge, what we mean by skills is also culture. Csikszentmihalyi talked about this, the impact of culture on what we mean by challenge and skills. That sort of like stretches this topic, out to like colossal levels. Do you even think about problems that way?
I do. The reason I do is, it depends what we mean by culture, but cultures is a pretty big topic. But I've, because I travel around the world, I used to travel around the world. Now I stay at home. But when I used to travel around the world, it made me think about things in a really global manner. That it was impossible to avoid. I'd give lectures, sometimes 5 continents in a year, and I got to see so many different perspectives on this same topic. And I realized that we know very little about that culture, people coming from different places in the world and the cultures they bring in, besides obviously all the numerous cultures even within a single country. We know that they're pretty diverse. I'm really interested in it. It's actually one of the reasons that we started a program at Neuroscape that the world will learn about very soon. I think I could tease it here because we've been working on it for a while. We call it the Remote Trials Program. And the idea is to be able to do large scale, larger than anyone ever has before, of like mobile randomized control trials where my dream is to be able to do studies of 1 million people, right? In the way that we can answer questions as complex as the one that you're asking, of how do all these different influences that you can only answer with very large numbers, how do they change how the exact same treatment or intervention is delivered and received.
Once you make that announcement, Adam, if you want to do some flow work on that, there's 1 million questions we'd love to work with you on at that scale.
Yeah, let's definitely return to that. I mean, we feel required to continue our research program, right? And so what we're excited about, until we're back into like MRIs and blood work and physiology recording, which we do at UCSF, we're putting all of our focus on trying to get these remote trials so that we can capture data from people in their homes, really important data like the anxiety and stress and how their sleep is varying in their mood, and children and adults, and then be able to put these interventions that have a very, low safety, risk, like our meditation game and other things, and be able to keep doing our work. So we're putting a lot of emphasis on that, and I will definitely let you know when we unveil that. It'll be soon.
Let me ask you a quick other question. I heard you say this once, that the average adult at work focuses on 11-minute chunks, but is interrupted on average 3 times over those 11 minutes. So we know from flow research on coders that if you're in flow and you get knocked out, it can take 15 minutes to get back in. When you're focused, right, in those 11 minutes, you're getting kicked out for 3 minutes. What's the adjustment cost to get back in? Forget your flow, just to like, how much time are you actually wasting trying? Out of that 11 minutes, right, you're getting interrupted 3 times. How much? What does it cost, just in terms of the switching costs, in terms of time?
Well, there's not a ton of data on that. A lot of that original data was observational data on workers, just watching how people behave at work.
Okay.
That's like real world data of just observation of how people engage, information technology workers, I think were in that study, how they engage in their workplace. We know that you can re-engage networks in your brain in hundreds of milliseconds. It's a very fast process, but it doesn't mean that you're doing it effectively. And so it's very possible that if you're being pulled out of your focus every 3 minutes, that you're never really hitting your flow and really engaging.
That's where I was going. Yeah, that's exactly where I was going with this. I'd heard that a long time ago when you said it, but when I was prepping for this, I watched part of one of the lecture you said that in, or one of the lectures you said, and it stuck with me again. And I was like, Jesus, that's an insane bit of data. And I don't know if you could ever get into flow if that is your situation. And it also made me wonder now with people at home. I've worked in an office. Put me in an office, I can't function. I've always worked at home, so this is ideal for me. But for people who are not used to it, right, it's the exact opposite. And I'm wondering if even like 11 minutes worth of focus is, that's just out the window. And it's an astounding cost.
I think it is way, way worse, because I'll have a lot of people reach out to me because they, have read my book, or they know my work, and they're just, I mean, that's why I started this talk by saying we're like in the third crisis is the mental health, using that globally. Distraction is a massive influence right now. Couple that with stress, couple that with being out of your routines. You know, it's gonna be an incredible burden, even for someone that is resilient. But for someone that's already struggling going into this, especially children that might not have the skills to be able to cope with this much, you know, uncertainty and change, it's going to be really, really debilitating to a lot of people. So I think that's true. That's all part of what makes me motivated to get our stuff out there more rapidly.
Mm-hmm.
And with you in particular, I would love to ask you a question we often ask folks at the end, which is if at the click of a finger, you could have any research immediately done. And then in your case, let's add to this question, if at the click of a finger, you could have any technology built with zero constraints, what would the research be? What would the piece of tech be? And I mean, obviously you've alluded to it already, but.
What's the science genie question?
Yeah,
I love that.
That's what we'll start calling it.
It's so satisfying for me even to think about it, because I can almost imagine that's true, and it feels so satisfying to just be like, hello. I would say that's actually easy for me to answer, because I've become sort of obsessed with this idea over the last couple of years. We'll be using it for all of our closed loop video games. We'll be using it in our psychedelic research program. And that is really meaningful, interpretable, real-time state recordings. We want to know where someone is in the moment with just, you know, milliseconds delay. I'll take a couple hundred milliseconds there, and really being able to understand. Obviously, we're not going to have the content, you know, but to be able to know their stress level, to know whether their valence is positive or negative, their arousal, whether their attention is internal or external, are they in flow, all of these things. If we had that accessible to us right now, there is just so much we can do with it to create better tools to help people. So I would take that.
Love that. Be a massive force multiplier, obviously, from there on out. So that's great. Adam, where can people find you? Where can they learn more, read more, support?
Yeah, so you know, I have a bunch of different access points. Neuroscape. If you search Neuroscape, you'll find our website, neuroscape.ucsf.edu. That's like our research center. Achille Interactive is our company. I didn't even talk about this. We have one of our first treatments is out there for the treatment of ADHD just a week and a half ago. I have a website, Gazzaley.com, that aggregates everything. We're redoing it and working on that right now, but that'll be the place that'll have access to all the different things I'm involved in.
All right, Adam, thank you so much. It's been amazing, and we're psyched to be back on the podcast again, 100%.
My pleasure.
Yeah, thank you
Great
so much.
questions.
Great to see you, brother.
I hope your listeners enjoyed, and looking forward to engaging again. I'll talk to you later.
All right, sir. Thanks a million. Bye-bye. If what you've heard on Flow Research Collective Radio has been helpful, please consider doing us a solid and leaving us a review on Apple Podcasts, Spotify, or wherever you are listening to this. Reviews help us connect to a wider audience so we can get these peak performance principles out to more people.